Next video in our topic set 1 is on quantities and units. Okay, so first we did just kind of a general overview of physics, then we went ahead and we looked at how to make measurements and kind of do that whole significant figure stuff. And now we're going to actually look at, okay, so we've made some measurements. Now we know that we have these quantities that we've measured. We know the units that are associated with them. How do we use those units and how do we use these different quantities? You'll notice that our subtitle here is Dimensional Analysis, which is the railroad to success if you had KIFE, or it's a domino game, or it's some way that we're actually using our units, the factor label method. Okay, so there's a number of different ways that we've talked about it as teachers, but it's the way that we make unit conversions. All right, so let's get started. First of all, we want to talk about fundamental quantities. Okay, we measure quantities. We go around this world and we say, okay, let's measure this or let's measure this. In fact, the book that I read from in the last video was always measuring things like length. Okay, length is considered to be a fundamental quantity. There are a number of different things that we always like to measure. In fact, you could probably pause the video right now and come up with at least 4. You should be able to come up with 4, and we'll address each of them. All right, so now the first one is length. Length is a quantity that we measure. We usually use a tool of a ruler or a stick or something along that lines to measure that quantity. And there are many different units that we can use or associate with the units or with the quantity length. We typically like to measure things in maybe inches or feet or meters or centimeters. These are all just units that are associated with the quantity length. When we start talking about all these different quantities in physics or in science, we generally have a standardized one that we like to go with. It's referred to as the SI unit. Okay, the SI unit for length is the meter. And so we usually like to see things in terms of meters when we make measurements. Now when we make measurements, sometimes we're going to deal with centimeters, but centimeters to meters is just a unit conversion, and we're going to talk about the unit conversions in a little bit here. Mass is another quantity that we like to measure. 2 probably big ones that we're going to use. All right, so we're back after that. Wrong number. Oh, I tell you, the phone calls that you get that are wrong numbers, or telemarketers, or anything. Anyways, back from our sidetrack here, we're looking at the quantity of mass. And as I was saying, mass is another one of those quantities that's kind of an important one for us as physics. We will tend to see that one as an important one when we get, especially when we get to topic set 4, where we start to look at forces. Mass is something that can be measured in pounds. It can be measured in kilograms, and usually those are the kind of 2 that we stay with, maybe grams. Grams, especially if you were going through chemistry, so we looked at a lot of masses in grams. The SI unit, though, is the kilogram. Okay, so that's typically what we like to see is kilograms. The tool that we use for that is a scale or a balance. So we either use a balance or we can use an electronic scale. Time is something that we like to measure. We typically measure time in years, days, months, hours, minutes, seconds. But the SI unit is always going to be in seconds. Okay, so our abbreviation for seconds is S. We like to use stopwatches for that. Sometimes we're going to measure time like with the tape timers. And that was kind of a good way to measure time as well. Temperature is the 4th of the 4 that I think you should have been able to get on your own. Temperature, generally we measure it in the quantities of degrees Celsius, degrees Fahrenheit, or kelvins, and the Kelvin is the SI unit that we like to work with the most. Amount to substance, for those of you that took chemistry, the amount to substance is always the mole. Okay, that's our SI standard there. Electric current is an amp. Okay, amp. And that's our SI unit. Okay, the amp or the ampere, it's kind of an abbreviated one. We'll use that one when we get to our electricity unit, and then our wave light unit, we'll talk about luminous intensity, and that's the lumen. Okay, and so that's our standards that as we go through the 7 fundamental quantities. Yeah, there's only 7 fundamental quantities in this universe that we can measure. And what does it mean to be fundamental again? It means to be the basics, okay? It's the basic ones. Now we kind of go from our fundamental quantities into derived quantities. A derived quantity is one that's made up of the fundamentals. My analogy for this is like I used to coach basketball, and so when I was coaching my 9th grade team, I would first teach them or work with them on dribbling skills, we'd work on passing skills, we'd work on shooting skills, and those were kind of our fundamental things that we needed to be able to do to play offense. When we incorporated an offensive scheme in, that's where we had to understand how to pass, shoot, and dribble. That's where we made a derived thing from it. A lot of times when we deal with derived quantities, we're thinking in terms of formulas, okay? There's probably a mathematical relationship. If you can think of the formula for it, then it's derived. If you can't think of a formula for it, it's probably a fundamental, but remember, there's only 7 of them as fundamentals, so you may come across one that you just don't know the formula for yet. Our first of the easy derived quantities is volume. And you might say, well, how does volume become derived? And if I think in terms of my formula, it's length times width times height. Okay, it's typically our formula for finding the volume of anything. The lengths, the widths, and heights are nothing more than lengths. Okay, so it's the quantity length times a quantity length times a quantity length, and that's how we get volume. When we do this, of course, we're given certain units or new units that are associated with it, and it's always a cubic unit. So in other words, it's like inches cubed or meters cubed. The other way that we deal with volume, though, is we have a tendency to measure liquid volumes, okay? So the volume itself, in fact, the way that volume was defined first, or I should say the way the liter was defined first, was by taking a cube that was 10 centimeters by 10 centimeters by 10 centimeters. So it was 10 centimeters, 10 centimeters by 10 centimeters. If you multiply that together, you get 1,000 centimeters cubed. And that's how they defined the unit liter. So 1 liter was equal to 1,000 centimeters cubed. Now what this tells us is that 1 milliliter is equal to 1 centimeter cubed. And so that's kind of one of those standard conversion factors that we're going to talk about here in a little bit. That's the way the liter was defined. But that puts us into a whole nother realm of quantity, or I should say units that we can use for the quantity volume. So we can measure things in cups, ounces, pints, liters, milliliters, gallons. Okay, so those are other ways that we can measure volume. Density is another one that we look at as a mathematical relationship. It's the relationship of the mass over the volume. Okay, so that's my relationship there. My unit types would be something like kilograms per meters cubed, or grams per meters cubed, or grams per inches cubed, or grams per centimeters cubed, or grams per milliliter. So those are all examples of something that would be a unit associated with density. The third one that we like to talk about, and again something that we did in 9th grade science, was speed. And speed was nothing more than the length, okay, over a given amount of time. So in other words, it was distance over time. And that gave us something in meters per second or miles per hour. So those were different units then that are associated with speed. Again, derived quantities are all based on something that we can find, or based on the fundamentals, so you can actually break everything down into its fundamental formula. Now the biggest thing is we start to do our dimensional analysis. And when we do dimensional analysis, there's a couple of things that I always like to keep in mind. The first is the conversion factor. And the conversion factor is a relationship between two things that are equivalent to each other. So like 1 inch, like 1 foot is equal to 12 inches. Okay, and it's usually set so that one of the values is going to be a 1. Another one that we know off the top of our head might be that 1 mile is equal to 5,280 feet. Now typically these are conversion factors that a lot of them we know already. We've committed them to our brains because we live in this country and we use those on a regular basis. The other ones are the bridge conversion factors. And a bridge conversion factor gets you from one unit system to the other. So in other words, the things that we measure in our country versus the rest of the world. An example of a bridge conversion factor would be like 1 inch is equal to 2.54 centimeters. Okay, it bridges us from our standard units that we like to measure, inches, feet, miles, etc., into the metric system, meters, centimeters, and that. Why do we like the metric system? The metric system is set up with a lot of prefixes. Okay, so it's a system where everything's based on prefixes. Centimeter. Okay, centi is a prefix that we use to describe the meter, okay, and it means part of, okay, and so there's some prefixes that are smaller and some prefixes that are larger, and we just vary it all off of a base unit. So like the gram, the liter, the second, they all can be base units, and then what we would do is then attach a prefix to it. Like you could have a centisecond, you could have a centigram, okay, there's a number of different types of prefixes that we can put in front of them, like a kilo, a hecto, a deci, a giga, tera. They're all just prefixes that we can use in front of those things. Now, how do we use these? Okay, and I can see that my video is probably going to have my head over right about here, so I'm going to make sure that I don't kind of write in that area. But we're essentially doing kind of either the railroad to success, or I like to call it the domino game. And the domino game says I start with, so this is my start, so I want to start with 2 centimeters and I want to get to something in feet. Now the rule is this: I'm going to look at this unit right here and I'm going to put the unit on the bottom, and I'm going to make this a conversion factor that's equal to like 1. Okay, and I have to start thinking, what can I convert into? And I want to get them to cancel, and in the end I want to end up with feet over here. So that's kind of the process of what I'm going to do. Now, why do I call it a domino game? Well, I'm looking at it as if I'm playing dominoes. So in other words, I have a 3 and I want to get to a 2. And I have conversion dominoes that get me from one unit type to another. So in other words, getting from a 3 to a 5 would be good. Now, if I play another domino on the bottom here, I have to have another 5. So I have to have a 5, and now what I'd like to have is a 2 up here. Now mathematically what we're thinking is units cancel. Okay, so like the dominoes cancel, and I'm left with what I want here. Numerically, mathematically, we multiply things that are on the top and we divide by things on the bottom. So let's go back to my example and kind of set up my example to see how to go through one of these. So I'm going to set it up. I'm going to go centimeters on the bottom, so the centimeters portion cancels. And I have to convert from centimeters into something that's going to get me towards feet. And I'm going to do that into inches. This is my bridge conversion factor. In 1 inch, there's 2.54 centimeters. And I always put a 1 by essentially the thing that's bigger and the number by its small. So I'm going to take the 2 and I'm going to divide it by 2.54. Then I have to get from inches into feet, and the bigger unit, of course, is feet. And I'm going to put 12 down there. And so I'm going to set it up, and that way I can do my canceling. So in other words, 2 divided by 2.54 divided by 12 should give me the number of feet. Now I'm just going to grab my calculator here. So I'm going to take 2, I'm going to divide it by 2.54, I'm going to, divide by 12, and I get my answer of 0.066 feet. Now typically, again, when we start looking at our significant figures, I'm going to round my answer to about the same number as I started with there. So I started with 2, I'm going to end with 2. And it's really about the fact that I made a measurement with a ruler over here that was only good to a near centimeter, and I made guesses at that. So it wasn't a great ruler. So it had line divisions for every centimeter, but not for every 1/10 of a centimeter, and I made a guess. And I want to have the same kind of level of ability or level of degree of certainty with my new measurement, and so my new measurement would represent that. All right, and that takes us through quantities and some dimensional analysis, and we'll see probably a question. I'll probably give you a question of convert something to something tomorrow in class. Okay, so good night, and we'll see you tomorrow.